So I will go over all of this at 10 o'clock. Okay, about all the information here. At 10 o'clock, we'll do a comparison between the review sheet and the test. We're going to go over the first 3 questions that you're going to see on the test. And technically, it's the first 2 questions. The reason why is in order to do that 3rd question, you're going to have to find slope anyway. So it's just a practice slope question. But when I do talk about the bonus questions, one of the bonus questions would be a question like solve for x with fractions. Don't be someone who runs away from fractions. No, that's not homework. So if you look at the assignment sheet, where it says review sheet, you do not have to turn it in. The only thing you're responsible for is turning in 1.1 to 1.9. As we talked about, you don't have to solve a problem that's got fractions in it. You undo the fraction. You multiply every term by the least common denominator and it undoes fractions. So what is the least common denominator for a 3, 5, 6? 30, 30. 3, 5, and 6 go into 30 evenly. So you would have to multiply each fraction by a 30. And if you don't know what the least common denominator is, then you take those denominators, you take the 3 and the 5 and the 6, those are the only denominators you have, and you take 2 at a time. 3 and 5, the first number each one can go into evenly is 15. The multiples, 3 goes into 3, 3 goes into 6, 3 goes into 9, 3 goes into 12, 3 goes into 15. And you can see that, all right, you got 5 goes into 5, 5 goes into 10, 5 goes into 15. So 15 is the least common denominator for the 3 and the 5. So you got the 15. But what about the 6? 6 doesn't go into 15. So we got to keep going. What else can 15 go into? 15 would go into the next one. The multiple of 15 would be a 30. So if 3 goes into 15, 3 will go into 30. 5 goes into 15, 5 will go into 30. And 6 goes into 30 as well. 6 goes into 6, 12, 18, 24, 6 goes into 30 as well. But you take 2 at a time. You could work the 5 and 6, the first number they divide evenly would be 30, and does 3 go into 30? Yeah, 3 goes into 30. So the least common denominator is 30. Take any 2 of the 3. If you have 4 different denominators, then take any 2 to start with, find those, that common denominator, then pull along the 3rd one, and then pull along the last one. It's like trying to pick up 3 friends and you're the driver. You pick up 2 at a time. What's the most easiest way to get those 2 people in the car? And then, okay, now we got to get that 3rd person. Okay? So everyone has to get multiplied by their own 30. Show this. And this is what I saw in my 4P class, the other class that I teach, Math 4P. When they did this, they didn't multiply by 30. In their head, they thought, okay, 3 goes into 30. They just multiply by 10. Because they can see that 3 goes into 30 10 times, so they're only showing the 10, which is not the same number. Because here they would multiply by 6, because they're trying to make 30, not multiply by 30. So nothing's reducing, they're getting the wrong answers. One step at a time. Multiply each one by 30. Each one gets its own 30. And then you simplify. This is the work I have to see. Shows me that you understand what's going on. 3 goes into that 30. Now I have 10. I have 10 times 4. That's 40x. Minus 5 goes into 30 6 times. 6 times 9 times x. that's 54x, plus 6 goes into 35 times, 5 times 7, that's plus 35x, equals 5 goes into 36 times, 6 times 9 is 54. No more fractions. No more fractions. Undo the denominator. In chapter 2, you're going to be solving equations that look like this. X squared equations. And you're going to have to factor or complete the square, or you're going to have to use a quadratic formula. Guess what? You don't want the fractions. You're going to undo the fractions. Find the least common denominator for 3 to 4 and 9. Undo the fractions. Make your life easy. So it's a good process. So here we got the next step. Simplify both sides completely. So before you start trying to solve this thing, clean up this left side. What's 40x minus 54x? That's a negative 14x. I still have plus 35 on this side equals 34 or 54 on that side. Simplify both sides completely. Now we're going to solve for x. We want to know what x equals. That's the whole point. So we got to get this negative 14x by itself over here. So what are we going to do to get this 35 over to the other side? Subtract 35. Subtract 35. So we're left with negative 14x equal to 54 minus 35 is going to be positive or negative. Positive how many? 19. Positive 19. You can't take 5 from 4. You have to borrow, so that's 4, that's 14. 14 minus 5 is 9. 4 minus 3 is 1, 19. But you know, you can use the calculator. Fine. And then it's negative 14 times x. What's the next step? You divide 14. No. Careful how you say it. Oh. Divide by. I didn't hear the negative 14. Negative 14. Divide both sides by negative 14 because we want positive x, not negative x. If you only divide by positive 14, and guess what? Let's say you divide by positive 14, and over here you put negative 19 over 14. You hit the correct answer, but your work doesn't give me that correct answer. How is positive 19 over positive 14 equal to negative 19 over 14? Because in your head, you're seeing, oh yeah, I'm dividing by negative 14, so that's negative. But that's not what you showed me. If I do this up here, somebody out there is going to say, how did you get the negative? Isn't a positive over a positive equal to a positive? Where'd that negative come from? I can't do it. I'm not going to let you guys do it. Because that's not true. Okay? It matters. Details matter. So if I want positive x, you have to divide by a negative 14. Now it's negative 19 over 14. Reduce it to lowest term, it's reduced. Because the only thing that I can reduce 14 with, that's 2 times 7, and 19 is prime. Nothing's going to go into 19. So final answer, the bottom of the box is going to be equal to negative 19 over 14. And remember, it doesn't matter if it's negative 19 over 14 or negative 19 over positive 14, or even if you left it positive 19 over negative 14. If there's one negative, the whole thing's negative. No decimals. Don't make a mixed number. Don't put 1 and 5/14. Negative 1 and 5/14. Because what if you make a mistake when you're trying to convert it into a mixed number? You have the right answer. And again, no decimal. That is an example of a bonus question. Because it's an algebra 1 question. Shul S question. So here we are. You will have one that looks just like this. I don't know what they did to the board yesterday. It's like, somebody took a message and the detective comes in and they find a notepad and they're, doing the pencil thing to see what they wrote this last note. And you guys have no idea what I'm talking about, so then maybe you do. So there's going to be a hint on your test how to do this problem. You're supposed to find the slope and the y-intercept at b. At the bottom of the test box, you're going to have what is m equal, what is b equal. So down here it tells you exactly what I'm looking for. What's m, what's b. The reminder of how to get that is going to be in this question over here. In this question over here, it says, write the equation of the line that passes through the given points in slope-intercept form, and it's even going to say, or comma, y equals mx plus b, just like it says in the review sheet. That's how you find the slope and the y-intercept. So there's a reminder. We have to get y by itself to figure out what the slope and the y-intercept is. So solve for y. If I'm going to solve for y, I want to leave y on the left side and I want to take the 9x to the right side. How do I take the 9x to the left? To the right side. Subtract 9x from both sides. Does it matter what order I write this in? It does. mx plus b. The x should be written before the constant. So this is negative 15y equals the x term, so it's a negative 9x, and then plus the constant. The constant's a negative 21, so minus 21. Now, is this the same thing? Is this negative 15y equal to negative 21 minus 9y? Is that the same thing? 9x. Is that the same thing? Is it the same thing? Yeah. They're the same thing. Because over here, you're combining a negative 21 and a negative 9x. Over here, you're combining a negative 9x and a negative 21. If I have negative 21 and a minus 2 versus a minus 2 and a negative 21, this equals negative 23, and this equals negative 23. So it's perfectly fine as long as you maintain the signs, the SIGNs. But the reason why you want it this way is because you're looking for the slope and the y-intercept. You want the x term and then the constant. In addition to this, remember that problem I put over here with the x squared? The x's should go from biggest power to the smallest power. The biggest power of x all the way down to the smallest power of x. So this is x to the first. This is an x to the 0. What's x to the 0? Don't make them give you the exponent goes again.
0.
If x to the 0 was 0, this would be negative 21 times 0, which would be negative, that would be minus 0. So that wouldn't be there. But because it is there, and it's just negative 21, this one has to be what? because everything to the zero power except zero is always one. Anything to the zero power, the power of zero is always a one. That would be exponent rule number 7. Out of our 10 basic exponent rules. But my point is, when you write a polynomial, and that's what you are writing, language. This is called, well, technically a binomial because it's only 2 terms. Biggest power always in arrangement. Biggest power to smallest power. X to the first, X to the 0. So we have negative 9x. Whoops. Okay. Still solving. Back to our regularly scheduled problem. I want positive y. It's negative 15 times y. So what do I do to get positive y? Divide by who? Negative 15. And not just go, don't do this, negative 15 and then negative 15. Well, first of all, first thing, do not do this. Do not just go, hey, negative 15. Okay? Don't do that. That ruins my week. Not just my day. Negative 15, don't do this. Because you have to simplify everything. Always simplify the low term. If you're going to do this, the only way you can simplify this is you have to either factor and then simplify every single individual, the common factors, or you're going to have to split it up and then simplify individual pieces. So why not do this? Remember the fraction problem? And I multiplied everybody by the common factor, the common denominator? Well, if I can multiply individual terms by the same number, I can divide individual terms by the same number. So if I divide one thing by negative 15, I divide everybody by negative 15. And that way it's all separated and I can find the individual parts that I'm looking for. Because now I'm just reducing individual fractions. And not trying to factor it to figure out what it is. All right. Right here, positive or negative? Positive. What is a common factor of a 9 and a 15? 3. So I'm going to actually write this here so I can show the word. Y equals positive. This is going to be 3 times 3 over 3 times 5 and then times x. And this is going to be a negative over negative, so what am I going to get? Plus common factor for 21 and 15. Another 3. 3 times 7 over 3 times 5. So the final equation, y is equal to 3/5 times x plus 7 over 5. It's nice to have this written down because now you're comparing it to what we just figured out. And you're just going to, what's the m? Good. 3 over 5. Do I put x? No. The 50-50 shot. Yes or no? The reason why, you see how the slope and the x are just 2 different things? So when I want to know what does m equal, m is just this part, not the x, the coefficient in front of the x. So the slope is just the 3/5, no x. And then what's the y-intercept? 7 over 5. 15, you just went, so you didn't show the factoring. Okay, so like right here, here's what I'm seeing. I'm not seeing. Okay, so here's what I see. How did you go from here to here? I don't see how the 9x made its way from this equation became this equation. I don't see how that happened. You went from that and it became this. Okay, is this is you correct? No, but I'm talking about how does this 9x end up on the right side? You have this, and then you have this. How does that become this? So from your first step to this step, how did 9x end up over here? Because you're not showing the subtraction. Okay, and so here, and it looks like you have division from that line. I'm not dividing by 9. I'm subtracting. So look where my line is. I subtracted 9x from both sides. Then I put a line under like where my subtraction takes place. Yeah. And now 9x is 0. All I have left is the negative 15y equals, and over here, negative 9x and negative 21. Then I divide each individual term by negative 15. Okay. Otherwise, if you go from here to just negative 15y equals, and you have negative 9x minus 21. If I did this, what happened? How did the 9x end up on the other side? Why is it now? Why is it negative now? Because people don't usually listen to me. You know, I describe it and I talk about it, but it's like, wait a minute. Because people, and it's not, you know, maybe they do tune me out, you know, family does, but they're also visual learners. They didn't see it happen. So that's why I have to see the step where it goes, all right, we're going to subtract 9x from both sides. So 9x minus 9x is 0. So I have a 0 and a negative 15y on the left side. I still have equals, and over here, negative 21 and a negative 9x made negative 9x minus 21. Okay, that's what I have to see. Okay, all right, slope. You are not going to have just this question where you just have to find slope. You know, to that we're done. Because you're going to have to do a question like that, write the equation of the line in slope-intercept form. So you can't do that question unless you know how to find slope. Slope. Rise over runs. It's the rise is the y. You subtract the y coordinates divided by you subtract the x coordinates. Seems like it was such a long time ago, and it was. So pick a y. What do you want to pick? The 23 or the 5 to start. 5. So if I start from this 5, this y 5, minus this y, which is 23, subtract the y's, over, we subtract the x's. If I start from here, this 5, I have to start the denominator from this x. This y sub 2 minus that y sub 1, that second y minus this first y, all over that second x, 24, minus, now it's a built-in negative, I'm going to subtract negative 6. So when I subtract the negative, putting it in parentheses is kind of important. Sign. So now my slope, 5 minus 23 is negative 18 over, this becomes 24 plus 6. So that becomes negative 18 over positive 30. And if I stop, it's not simplified. So this is, my slope's going to be negative, don't forget the negative. And, some of you are over here and see this word, and then all of a sudden you have that negative, and then all of a sudden the negatives have to get a little smaller. And pretty soon you forget to put the negative at all. Because you can't see where you wrote it. Forget it's negative. This is, common factor is going to be a 6. 6 times 5 over 6 times 3. So it's negative 5 over 3. Okay. Find your slope. If I use the other points, I get the same answer. If I do the slope and start with 23. 23 minus that y, 5. So if I start from here, I have to start from this x, negative 6 minus that 24. So that gives me a slope of 23 minus 5 is positive 18. Negative 6 minus 24 is negative 30. So I still have a positive over a negative, so my slope is still negative, and 18 over 30 is still going to be 5. I wrote this upside down. It's 6 times 3 over 6 times 5. No one said anything. So it's going to be 3 bits. You're like Chris Farley in the old Tyrant Bicycle. And another reference that I was alive when the original Saturday Night Live came up. Chevy Chase, Lorraine Newman. Bill Murray was not the original cast. I used to give that as a bonus question on a test when I was first started teaching. Who was the original, not original primetime players in Saturday Night Live in 1975? But then again, I started teaching in 1990, so they can answer that question. I don't know. I wouldn't suspect you guys. What was the name of the Howls on Gilligan's Island? And you would go, what the hell is Gilligan's Island? The first and how the third and love it. Okay, so we want y equals mx plus b. So what you got to do is you got to find out what m is and what b is, and then you plug them in. So we need the slope. So the slope, rise over run, rise over y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Which y do you want to start with? Negative 2. And this is where I will promise you it's going to work out nicely. You're not going to have a problem where you're going to have to deal with fractions to get the final answer. So we start with negative 2, which means if you are coming across this problem and it's like, okay, wait a minute, he said there's not going to be any crazy fractions to deal with. And I have crazy fractions, something's wrong, get up and x. Negative 2 minus y, 13 over, start from here, 20 minus 8. Negative 2 minus 13 is negative 15 over 20 minus 8, which is, well, reduce it to lowest term. Now, if you don't reduce it to lowest terms, yeah, you probably will have crazy fractions in the problem. So it's going to be a negative. This is 5 times 3 over 4 times 3. So the slope is negative 5 over 4. So we have the slope. Y equals negative 5 over 4 times x. We're almost done. We now have y equals negative 5 over 4 times x. We just have to figure out the y-intercept. To figure out the y-intercept, that variable, we want to plug something in for x and y. If only we knew of a point that is on this, and we have two of them. We have 2 points that are on the line. Pick one. Pick an x and a y that we can plug in so we can solve for b. So which one, the 813 or the 20 negative 2? 813. So if I use this first order pair, if I use the 813, and this is what we've been doing the last 2 weeks, substitution. Where am I going to plug in the 8 for who? X. 8 is the x and 13 is the y. I'm going to let x equal 8 and y is the 13. So 13 equals, and this is what I mean by no crazy fraction. Negative 5 over 4 times x is an 8. Y is my 13th. And then remember, we're solving for b. So simplify, 13 equals negative times a positive is a negative. 4 goes into 8 nicely 2 times. That's what I mean by no fractions, no crazy fractions to deal with. Negative 5 times 2 is negative 10 plus b. And what will I do to solve for that b? Add 10. So b is 23. And that's what we were missing here. We needed to know what the b was. And we just found out that it's the 23. So the final answer, y is equal to negative 5 over 4x. And that b is a plus 23. Here's how you know it's right. If you have the right equation, then if I plug in this ordered pair for x and y, it should be a true statement. So if I let y equal negative 2, and that equals negative 5 over 4 times x is 20, and then I add 23 to it, if I can get this equal to negative 2, I have the same equation. So negative 2 equals negative times a positive is going to be a negative. 4 goes into 20 how many times? 5. So this is negative 5 times 5, so negative 25 plus 23. So this negative 2 equals negative 25 plus, yep. When I plug the other order pair into the equation that we made, it works. So this equation goes through those 2 points. So I know I have the right problem. I have the right answer. This problem right here, that problem, this is question number 1 on the test. That's question number 2 on the test. Just different problems. Exactly the same question, different problems. No surprises. I don't believe in surprises. I want to make sure you're ready to take the test. Now, whether or not you practice to be ready, I can't control that. But you know exactly what to expect. You know exactly how it gets done. Can you reference it when you're studying at home? Well, if there's only some way to like pull up what just happened in case you forget what just happened, like some kind of, I don't know, memory device, some kind of like visual remembering button to click. And maybe somebody sent me some kind of way to remember what just happened. Like, well, I know it got screwed up on Monday because, you know, so it's probably going to screw up all the time. Sorry, sarcasm. Talking to a friend, he teaches third graders. He says when he tries to be sarcastic with third grade, he makes them cry because they don't understand sarcasm. No, I wasn't, I didn't mean it. It was just like, sorry. Don't go to grade. Back at 10. And then it is on you to tell, once we go over what you're going to see, to tell me what you want to do.